Hello, everybody. Welcome to today's webinar, Geosynthetics Used in Paved and Unpaved Roads. This presentation is brought to you by the Geosynthetic Materials Association, GMA, and sponsored by Propex. My name is Drew Loazzo. I'm the Engineering Services Manager at Propex, and I will be your moderator today. Thank you guys for your time and the ability to come and join the webinar with us. Before we get started, I want to go over a couple items just to help you understand how you can participate today in our webinar. You will have the opportunity to submit test questions to today's presentation and to George, our presenter, by typing your questions into the question box by the control panel. You may send these questions at any time during the presentation, and we'll collect them all and address them at the end during the Q&A session for today's presentation. So now I'll introduce our presenter, Dr. George Kerner. George Kerner is the director of the Geosynthetic Institute. He is in charge of laboratory accreditation, field certification, and continuing education at the Institute. He also manages several research projects and has published over 300 technical papers in his 35-year association with polymers used in below-ground construction. Dr. Kerner's PhD is from Drexel University in geotechnical engineering. He is a registered professional engineer and a certified quality auditor. George, if you guys don't know George, he is a huge influence in our industry and a great support and a great resource. He's got a lot of great stuff to tell us today. So thank you, George. Thank you guys for your time, and I'll hand it over to you.
What a neat intro. Thank you so much, Drew. It's an honor and a privilege to be with you. Geosynthetic in roadways. I have to give a shout out to Propex for their support, but also to Mark Marienfeld. Mark did a technical review, and he really supplemented this presentation nicely. Talented guy. Here's his contact information. And Mark, thank you very much. Really, everybody's better when they're reviewed, and I'm included in that. As an overview of the webinar and outline, we're going to go through an introduction and background. We're then going to go into unpaved roads. And then the paved road section will be subdivided into three sections. First of all, the geosynthetic on the subgrade, between the subgrade and the base course. Then geosynthetic with inside the base course. Then the geosynthetic in the pavement. And then finally give a summary and conclusion. This overview, worldwide statistics. This appears in our most recent white paper, which is white paper number 44, which was available in March 2020. It's on our website. The market is enormous. Here you see the top 12 countries in regards to paved and unpaved roads, either in kilometers and miles. Please realize these numbers are multiplied by 1,000. So the grand total is down here in red, and it's just staggering, the size of it. And the market is enormous, and I submit to you, ever growing. The materials that we're going to talk to you about are geosynthetics, most commonly geotextiles and geogrids. The textiles are broken down into non-wovens and wovens, mostly polypropylene and PET. A lot of varieties, and arguably the oldest of the geosynthetic materials. Geogrids, three type, punched and drawn, coated, or strap type, made of a bunch of different materials, but even more variety in this group of materials. As far as geosynthetics in unpaved roads, we're really looking at three primary functions. One of separation, the other of stabilization, and the fourth of reinforcement. Please realize that during this application, the material is very weak. We're typically talking about unpaved roads because a DOT or state will not pave on a subgrade that's poor, let's call it in the neighborhood of 1 or 2 CBR. So when it gets less than that, they have great trepidation about paving it, and it's due to there just wouldn't be longevity in a road like that. There's just too much movement. As far as unpaved road design, this is a superposition of various strength relationships of shear strength. We see CBR here, shear strength, and also cone index. So we're talking about very soft soils in the neighborhood of a CBR of 1. Interesting to note from a geotechnical perspective, you are benefited greatly by moving from punching to general shear. You get almost an 80% increase in strength by doing that. And this, in truth, is what the geosynthetic is doing. Non-stabilized versus stabilized, you see the bearing capacity factors, and you're significantly increasing that with geosynthetics. Unpaved roads can be extremely soft. Here we're nearly walking on water. CBRs are less than 1 in this particular case, placing the geotextile and then subsequently going on top of it. Here is more common the case where you have a soft spot in a roadway in an unpaved road. You have tremendous rutting. This rutting in the roadway is an issue. It's an issue with the aggregate mixing with the subgrade, the fines migrating up into the aggregate and rendering it ineffective. Geotextile in this regard would help tremendously. We have several designs. One of the most notable one is Giroux-Norey, which is back in 1981. It shows the increase over extremely soft subgrades by using a geotextile or a geosynthetic. They updated this in 2004 and 2012. I would send you to that reference. I think it's a very powerful one. In truth, what you need from it is modulus. And regardless, if you have a geotextile or a geogrid, you're going to need the initial modulus of the material. And you obtain this from a wide width tensile test. This wide width tensile test, the red portion of the curve is an indication of the modulus. This is a stress strain curve. And the faster this picks up load, the better it will be at helping you in an unpaved road situation. This I've pulled directly from the Giroux-Norey plot. This is their plot directly from the journal paper. Bob Kerner simplified it here. Look at thickness of stone versus the strength of the, or CBR of the material. You're now looking at the yellow curve, which has no geotextile in that case. You beam up, let's call it from a CBR of 2, and then go over. You're looking at somewhere in the neighborhood of a foot of stone required for this particular application. The second example, which I'll run for you, is a geotextile with a modulus of around 1,000 pounds per inch. You again go up at 2, beam over, and you have 8 inches of base required. In synopsis, we've gone from without a geotextile for 12 inches. We moved with a geotextile to 8. There's a savings straight off the bat for 4 inches of material. Thus, the economics of this are justified immediately. Stone costs a lot of money, and in this day and age, it's costing more and more money. Quarried stone, there's less and less quarries. It's at different locations, it's different prices, at different grades. This is all much more complicated than transporting a geosynthetic or a geotextile to your site. From the perspective of a transportation cost, if any of you have shipped anything recently, are just skyrocketing. It also keeps the trucks off the road. So from the perspective of a sustainability standpoint, geosynthetics make a lot of sense, and it's a win-win situation here. Really, in this application, I see geosynthetics having great benefit cost. Cost of effective ground improvement. You see different applications here with varying degrees of subgrade. In certain cases, you will seam this material, particularly if the geotextile is very strong and quite expensive. The seam has to be checked as far as the seam efficiency is concerned. I've seen some clever contractors even accordion fold their material on site The center has a center cable, which is for a pull. They've accordion and stacked the material, and they can extend the cable and then make two different pulls of the material. I've seen this technique over soft subgrades up to 1,000 feet. So you're in the neighborhood of a football field that you're running with this particular technique. It works quite well, and there are quite a few clever contractors that have this technique down. You're also aided by a lot of very good construction equipment. These construction equipment vary from low ground pressure dozer, amphibious track hose. We've seen stone slingers and dump trucks, which are lightweight, which you can get over soft subgrades. All of this is utilized with geosynthetics and utilized quite well. I have to point out to you that if you are overlapping and not seaming, it's quite important to overlap so that it's shingled downward. So you're pushing fill over top. You don't want to unravel this. The principal direction of stress is cross the longitudinal axis of the roadway. So this is sometimes beneficial to have material specced out this way. You will push it from this end. They'll end dump the 18-kip dump trucks and then spread with the dozer coming forward to us in the foreground. In addition to that, you don't push a single line. You would like to push a leading edge, and what you're trying to do is trap the mud wave underneath the geotextile. You'll push the edges first and then come back with pushing the center. This photograph here of a ballooning up of the geotextile, that geotextile is behaving quite well and acting in your best interest. You certainly are taking advantage of the modulus of the material. This is not the case in the figure below. This geotextile here is a lot of slack is in it. They're discussing here in the background, how do we get that slack out of it so we don't incur a tremendous amount of settlement. This is a much better case here where you see the tensioning of the material. Okay, that was very quick, but that was unpaved roads. Now I'd like to go into a paved road situation, and I'd like to talk about three situations in the entire sequence, in the entire group. I will work from the bottom up. So I'll talk about a geotextile or geosynthetics placed on the subgrade, then geosynthetics with inside the stone base, and then finally asphalt geosynthetic in the pavement, whether it be asphaltic or concrete pavement. Three major locations are discussed, and please realize it's from the subgrade up. Mark Marienfeld produced this. We sort of cleaned it up. But if there was a take-home message from this section, it would certainly be this slide. Please realize you have a wheel load, and the most important wheel loads that you're incurring are wheel loads, the heavy wheel loads. 18-kip wheel load is typically used for design. The different sections which are represented here, we have the pavement, the base course, and the subgrade. Please realize that the pavement is strongest. Weaker layer, a little bit weaker layer is the aggregate, and the weakest of the entire group is the subgrade soil. What we're doing is you have progressively stronger layers moving up through the cross section, and this is to support the load. And basically, the geosynthetics are functioning to preserve or enhance these layers. And that in red is a real key message. The geosynthetics are acting as a catalyst to improve these layers, or just improving them outright in tandem with the existing natural soil layers. But to preserve and enhance are what we're going to be talking about through this entire section of paved roads. The primary functions of the geosynthetics, this is hotly debated. And I submit to you that all 6 of these items, these functions are can occur. You can have separation, stabilization, reinforcement, a hydraulic enhancement, drainage, moisture barrier, or stress absorbing layer or a bond breaker. We'll talk to all 6 of these, but I think which one is the primary, secondary, or tertiary? You might have applications where all of these are included in geosynthetic, which are used in paved sections. As far as design options are concerned, there are 2 major items which sort of morph into 3 items. The first item is that with these designs, you're reducing the structural section and saving aggregate most often when you use geosynthetics. This cost savings could be significant. We showed you that in the previous unpaved roads, but it comes to fore in the paved section as well. In addition to that, you could use the geosynthetic just to extend the service life of the material. And the third section here could be a combination of 1 and 2. So think of things in regards to reducing the structural section or extending the service life, or a combination of the 2. This is again a Mark Marienfeld slide, and if you would, I hope I bring your attention to this and concentrate on this. It's very important. As far as the transportation infrastructure assets are concerned, probably the one that's most ignored and the one that's most taken for granted is that unbound aggregate. That aggregate is expensive, and it probably does the roadway the best benefit. It certainly is the roadway foundation layer. It's a key element from a cost-effective standpoint, and we truly think it's the most ignored transportation asset. And think if you can preserve this for long periods of time, you'd be a winner in regards to benefit cost and utilization of the resource. What occurs to this resource? You progressively lose the integrity of it if it migrates down into the subgrade, or the subgrade comes up, or the fines come up into it. We typically have a known layer and a known design associated with it. If it loses its integrity over time, things begin to falter, and certainly we'll have structural failure, and then finally distress up into the pavement section. You saw that in pictures previously. Here it is in real life. We've opened up the bituminous asphalt, and you see fines migrating not only up through the pavement section, but also these fines migrated all the way through the base course, the alligator cracking and the staining from the iron oxide rich subgrade soil. Here, this is a real winner of a slide. This is Mark's slide as well. This is the subgrade soil. This was base course material. The base course material, you can see a little bit of the aggregate poking out of it, but this base course has been totally compromised by fines migrating up into the base from the subgrade. Mixing occurs, and this mixing really reduces the structural integrity of that base. Not only to say it on a qualitative basis, but to quantify this, there's quite a bit of research out there showing this in true form. What we're using is, this is modulus with respect to percentage of fines. And we see here that once we get over about 6% fines with inside the base course, the modulus of that material goes to heck in a handbasket. Introducing contamination in single digits, 6 to 8%, you're seeing a tremendous drop off in modulus of material. The strength is dropping off at 50% with 13% fines in there. In addition to the strength loss, you're having tremendous losses in regards to drainage, and drainage could arguably be the most important factor for good base course materials. Contaminating road base, you're losing a tremendous effectiveness of this base once it becomes contaminated, and there's no way to get that back except for full depth repairs, which are quite expensive and time consuming. Here you see base course failures, how they manifest itself. Here, this is the shoulder and the actual concrete and then asphaltic roadway. It's weeping moisture, and this material, as you see here, is again contaminated quite significantly with fines up into the base course, compromising its integrity. The solution to this is a heavy, stout, needle punch non-woven textile sitting on the base course of the the subgrade of the material before the base course is placed. The installation is quick, easy, and doesn't slow the contractor down one bit. The concept of a flexible pavement aggregate base is extremely important, and it's getting a lot of traction now throughout the states through AASHTO, but also in FHWA. And they're terming it as a permanent road foundation. And to keep this as an asset, we talked about that a little bit earlier, but extremely important to keep this permanent road foundation intact, and then subsequently just work on the surface of the roadway. Do not go in after full depth repairs. And we can do this only with a geotextile separator, separating this layer and making it nice for the future. As far as the rigid pavement is concerned, this is also the case with concrete. Please realize the concrete, when it starts to fault and rock, it pumps fines up into the aggregate base and compromising it. Excellent studies were done at Penn State back last year in this regard. And again, to have that open, free draining permanent roadway foundation is going to come back and save you money in the long term. Solutions for this are certainly to have a stout needle punch non-woven sitting on the subgrade, keeping that base course in good order, strength-wise as well as free-flowing. Then the roadway will stay intact for longer periods, and when it starts wearing out, it certainly can be serviced with respect to time. Cost justifications for this geotextile, which is acting as a separator predominantly and stabilizing the situation, not letting fines move up through it. The geotextile costs less than 1 inch of aggregate, and please realize that it compares to about 4 inches of aggregate loss due to contamination. So right off the bat, it makes sense to include this geotextile as a separator. It enables to have more open graded aggregate, and that is the key. We're seeing open graded aggregate rather than modified base courses. They're free flowing, and you can do that with a geotextile separator. You can keep the fines out of the base and use a more open graded stone in these applications. It replaces more expensive, less effective foundations, and it's a very good compensation for weak or wet spots. It prevents that total road reconstruction and certainly is very cost effective. Going back to that concept of permanent road foundation, it's a new initiative in FHWA, and the real benefits of that are seen during reconstruction. Please realize that you can do a surface reconstruction fast, overnight, and inexpensive compared to long, lengthy delays when you close the entire road right down. It dramatically lowers the cost of things, and you avoid downtime. So there's a lot of benefits to this concept of permanent road foundation, and we think we'll be seeing quite a bit more of this in the future. most current transportation initiatives, you see it before you. This is a proactive approach rather than a reactive approach. And I submit to you, over the last 25 years, we've been doing a reactive approach, and this is maybe a time for a paradigm shift to get proactive and behind the concept of permanent road foundation. Proven performance. We're looking at Oklahoma now, and Oklahoma has been doing this for about 25 years. They're finding that they have a tremendous cost savings in regards to using the geotextile as a separator. It's saving a lot on aggregate, and it's giving them anywhere between 5 and 15 years more of service life. They're finding it a real winner, and it's used quite readily. From the Oklahoma study, we're seeing this. If you would have a 5-lane roadway, if only 30 foot of it needed to be full depth repair, this would justify the use of the geotextile over the entire roadway. So the cost of this is, the geotextile is minimal, and the benefit is certainly tremendous. We're seeing it also from the perspective of life cycle cost analysis. Here you see the two comparisons, one left and right. You're comparing the geotextile. One truckload of geotextile equals about 700 loads of aggregate. And this is a dramatic increase from a sustainability perspective. And it also is, we're trying to be good stewards of the resources at hand. So again, from this vantage point, the geosynthetic, the geotextile as a separator is a win-win. What is the best geotextile or separator in this regard? I do believe that it is a textile. It can be a textile incorporated with a geogrid, but when you have fine-grained materials with open-graded bases, we're seeing a geotextile used most prevalently. An FHWA study pointed this out, and this is for these actual materials. The subgrade material did migrate up into the base when a geogrid alone was used. When a geotextile was used, that base course was rather free and open up. What type of geotextile should you use? I submit to you, look into AASHTO M288. This will give you guidance in regards to the geotextiles and the specific survivability requirements for those textiles. You'll see the 3 classes of material: Class 1, Class 2, and Class 3. Class 1 material is the most severe. That's from an environmental standpoint as well as an equipment standpoint. Class 2 is common, and Class 3, we're using this only on cases where we can really control the environment and the equipment that's used on site. Class 1 is the harshest, and Class 3 is the weakest. 2 is the most common used that we see. GSI is also doing considerable work in this regard. We have sites now that are aged to the point of 20 to 30 years old. We've bore this out in research, and it's nice to see that PennDOT has taken this on quite well. We have different sites all around the state as well as the Northeast, and now PennDOT requires a 12 ounce per square yard of 410 grams per square meter textile, needle punch non-woven, in all pavements now where they're doing full depth repair. So we've seen this research bear out from many different sources that it really pays to use a geotextile separator between the subgrade and the base course. Okay, now looking at geosynthetics in paved road applications, we're going to a more competent CBR material, and we're typically now having firm subgrades. And what we'd like to do is increase the number of easels or increase the design life of the roadway system. There are many different pavement models which we could use. In the last scenario, the separation models, I last counted about 15 models that are available for you beyond which I showed you. But here, there's almost 30 or 40 models, and I think this is a favorite master's thesis for people to undertake. If you want references on this, certainly reach out through the GMA tech line or to my email directly, and I can give you a listing of this. But it's tremendous the amount of work that's been done in this area. As far as the defining these models, I can certainly give an entire webinar on just the design, pavement design with geosynthetics. And sort of to summarize this, I know it's great generalization, but we see most of the models are giving a 20 to 30% reduction in structural section when a geosynthetic is used inside the aggregate base. Other designs result in a greater traffic number. So again, you either reduce the cross section or extend the lifetime. That's similar to what we showed earlier on. But the big item is that the number 4, some of these geosynthetics improve the performance, the hydraulic performance of the base course, and particularly when you're using a modified base. It's always important to consider a geosynthetic as a comparison to traditional materials. I submit to you that the geosynthetics are a nice alternative to heavy and tough to find sometimes natural materials, particularly stone-based and crushed and quarried stone. As far as the stone is concerned, it's benefited greatly in this application from geogrids which have an aperture associated with them. If you match the geogrid with the aperture size of the stone, you have a nice partnership. This partnership will lend itself well to reinforcement and stabilization of that base course material, which is advantageous for the longevity of the roadway. It will improve the load distribution as well as the lateral restraint inside the roadway cross-section. You have to ideally place the geogrid in the base course itself, but the savings, the delta H here, could be quite significant with the addition of a grid or textile in the base course. This is one study. It's from Germany. I particularly like this. I was on the review for it. It's the inclusion of geosynthetics in the base course material. This improvement, you see the unbound versus the geosynthetic bound material. This is settlement with respect to surcharge loading. The geosynthetic cross-section outperformed the unbound or the non-section tremendously by threefold. Here you see yet another study. This is in regards to rut depth. We're looking at date on the x-axis versus rut depth on the y-axis. The dark blue curve here is the control section. And you see after about 2 years, rut depth became significant in regards to the pavement, the asphaltic pavement. With both the textile and the geogrid, this almost looks like it's going out to equilibrium. And certainly you've extended the life and improved the quality of the pavement tremendously by the inclusion of the geogrid or geotextile in the base course. This is an old slide back from 1987. A good friend, Bob Carroll, did this work. Usually the geosynthetic placed with inside the base, and what he's looking at is equivalent reinforcement base thickness versus non. And here you have 10 versus 15 with the inclusion. So there's a savings in the neighborhood of 5 inches of base course, which can be a significant cost savings. which is interesting to me is how Bob has the boundary conditions. He certainly doesn't want anybody to use a base course less than 4 inches, which I think is well founded. Why this curve is linear, I've asked Bob that several times. I kind of think it's S-shaped rather than that, but never had the research bucks to go after it. But a fascinating curve, and I think it's very descriptive on how well geosynthetics work in the base course itself. So improving the hydraulics of the base course, this isn't really needed when you're using open graded gravel, but when you're using modified base courses, it can be quite significant. A heavy needle punch non-woven textile would dissipate poor water pressures laterally. Some clever manufacturers have some neat materials, some innovative materials, which will wick water directionally. And it'll also help you in regards to capillary rise, which could occur in fine-grained materials, particularly silts and clays of the CL/ML variety. Summary of the research really will extend the service life 2 to 3 times with the inclusion. As far as the easels are concerned, we saw that 20 to 30% improvement with the materials. Effective transition layer, obviously good cost effectiveness. There's a lot of designs out there. Certain states really do yeoman's work in regards to transportation. Penn State is good, but I would think direct you to University of Illinois. Amadi Quadi has done it for years there with some tremendous research, and you can certainly get a lot of technical backup from that work. Geosynthetics now, we're moving up to the 3rd layer inside of the pavement structures itself. As far as the function, you're creating a moisture barrier. You could be creating a stress absorbing layer, and then you could be reinforcing the pavement. This is applications which we see it both with asphaltic as well as concrete pavements, as well as chip seals. So you really have 3 different functions, as well as 3 very different applications in this regard of geosynthetics used with inside the pavement. We're truly talking of this. You might have a cracked pavement, which you'd like to place an asphalt overlay. Here, a geotextile or geogrid, or a combination of the 2, is placed on top of the cracked pavement, and then you place the overlay over top of it. I'll show you a couple construction sides. Critically important to this entire procedure is to use a emulsion of AC to tack down the geotextile. The geotextile is typically a 4 ounce per square yard, maybe 5 ounce per square yard needle punch non-woven textile. And this is the biggest use of geotextiles in the entire purview of transportation. It's seen about 50 years of use, and certainly is the most widely successful use of geotextiles in the transportation area. Key element to this is a uniform tack coat. This is an asphaltic cement, which is placed at 0.25 gallons per square yard. It's spray applied just in advance of placing the geotextile over top of it. The pavement has to be dry, and that's a caveat that you should know. The pavement can't be wet. It should be dried and dried out significantly. The tack works much better in the dry. Next step is to install the textile. The textile should be spread. They have automated equipment, which works quite well, and sort of brush it in to the tack coat. Quick and easy installation does not slow down the paving operation. It can be trafficked, but you shouldn't traffic it excessively. Obviously, if you're damaging the geotextile in the drive lane at this point, it's not a good thing. So drive on it sparingly and be cautious how you enter and exit the textile. No sharp turns and obviously no hard braking. Your speed should be controlled. You should place at least 1.5 38 millimeters of asphaltic concrete over top of it. Don't get any less than this. That's shown not to work well. The heat of the asphalt will actually draw the AC up into the geotextile and saturate it. It works very well. Again, don't excessively traffic the material and move on as you go. The geosynthetic, what is it doing in this application? It's behaving as a moisture barrier. It also can add in regards to fatigue and reflective crack remediation or retarding. It enhances a chip seal, and it also can behave as reinforcement. Let's take a look at that. Here you see in this cross section, this is the old pavement. Here's the geotextile, which has been saturated, and subsequently the new asphaltic concrete over top of it. We're seeing a resistance of this crack from propagating. We're also seeing this saturated layer of geotextile, which is performing well as a moisture barrier. The moisture barrier is critically important, discussed heavily at TRB. Keeping water out of the pavement is critical, and that's been known to extend the life of these pavement cross sections multiple years due to the moisture barrier alone. Primary issue is that when moisture enters into the pavement, it actually softens both the base course and the subgrade soil. You can have pumping of fines up through if you do not have a geotextile separator. Poor water pressure could build up in these layers, particularly if they're well graded. Have issue with freeze thaw and expansion. Swelling clays and then drying subsequently in the subgrade soil, and these big moisture swings have issue as far as roadway structural number. Culmination of this work is by an FHW report. This is probably the most famous of them. It's from Harry Cedergren, who was a Caltrans engineer for years and showed us the way in regard to water inside the pavement. He's showing you a drain section versus water in the pavement, and significantly compromised due to water in the section. If the pavement section is saturated 10% of the time, the useful life of the roadway is reduced by 50%. And that's a significant finding. And sure, the take-home message is to keep water out of the pavement. And how do you do that is with a geotextile in the pavement section, saturated with AC. You can also approach it from structural credit for drainage. AASHTO has a series of calculations for that, which I'll show you in the next two slides. AASHTO has a drainage coefficient, and this coefficient, there are two examples. If you have 8 inches of base course and the SN, the structural number is 0.14, and you have the base drainage coefficient of 0.6, which is kind of a poor value, you get a certain structural number. If we'd run through the exact same scenario and gave that drainage coefficient a 1.2, an excellent, then we'd move up that number significantly, almost 2 times. By draining, you get a tremendous advantage. You see that from the previous curve, and you can also see it from this design example. Stronger, long-lasting pavement at less cost. It's a win across the board, and the geotextile really pays dividends from a moisture barrier perspective in that regard. Bob Kerner's Designing with Geosynthetics addresses the waterproofing characteristics a little bit differently. He goes through a representative rebound deflection number, and subsequently is looking at that with geotextile and then without. Here you see his design curve. This is the overlay thickness versus that number. The savings associated with that translates into about 30 millimeters, which works out to a little bit over an inch of asphalt, which is being saved, so certainly significant. In addition to moisture barrier, that geosynthetic can serve to retard fatigue and stop reflective cracking. We've had quite a bit of research in regards to this. The TRB work, which is co-authored by Mark Marienfeld, is quite well known. You will have savings of asphalt and also an improved roadway. Here you see that work in retarding reflective cracking. Excessive joint movement is mitigated by having that saturated zone in there from absorption as well as structural performance. You see it in regards to chip seal as well. This is used particularly in the southern states in the United States. You have a longer chip seal and a prevention of the cracks growing up through it with the use of the saturated textile in that application. You can also have a peel and stick, which is a much more robust geosynthetic in this regard. These are typically woven or glass grids, which are set inside of a tack, a membrane. These are laid down in sheets. You see it on the right-hand side being laid down on a bridge deck, and this is an approach abutment. You even see them in airfields being used significantly before placement of overlay layers. Fiberglass grids and grid composites are used in this application. You see a lot of different items used in paving, and what works in a given locale is sometimes site-specific. We're getting quite a few case histories in this regard, and this is supporting the technology in a very technical way, which is a good thing. As far as reinforcement is concerned, this fabric effectiveness factor is also shown in Designing with Geosynthetics. It's backed up with laboratory data as well as some field data. That both translates into a design traffic number with and without a textile, and you can see the benefits directly of using the material. This is the design nomograph, the chart, which is extended period. You're again having a savings of the material when using geosynthetics. The asphalt is expensive, and you can recoup that expense quite readily with a geosynthetics. Considerations for choosing an interlayer: the pavement condition to be addressed. Certainly the moisture damage, if that damage is from frost, heaving, pumping of the base. If it's a full depth repair, you're not going to solve it by a Band-Aid on the surface. Please realize that. Reflective cracking, the loads that are induced, thermal cracking, oxidation, or disbonding. I'll point out to you that there are a bunch of additional considerations for this as well. The pavement loading, pavement foundation, and the budget are certainly important. But that second item there, the climate, has to be honestly discussed. These techniques work best below the Mason-Dixon line in the U.S. In the northern climates, we have had success with some, however, others not so much. So talk to your local engineers, see what they've experienced in the past, and when you're trying a new thing, be upfront with it. But certainly there are new ideas which can work quite well. Considerations for choosing it, the pavement surface, the installation considerations, and then recycling considerations. This last one in here is quite important. I hadn't realized the severity of this. Mark added quite a bit to the presentation in this regard, and I think his comments were very founded, and that's why I included them to follow. As far as resurfacing, particularly with the permanent foundation of the aggregate, we see that we'll be doing more of this. This is a high percentage of the pavements today in the U.S. are being remilled. They're then being reintroduced into the overlay in the neighborhood of 10 to 20%. It poses an ability to mix in the inner layer. You certainly have to do this very rapidly and very quickly, and you can't be binding up the milling machine. In addition to that, the milling machine is, which it's creating, is a very rough surface. This rough surface typically has 120-degree grooves associated with it. The milling is done quickly. Unfortunately, or fortunately for some materials, it's requiring a lot of elongation, 25% elongation. And this lends itself well to needle punch non-woven textiles. It does not lend itself well to materials which are very stiff and with a high modulus. So you need flexibility here. This has been pointed out in a laboratory as well as the field. The laboratory test that they have set up is like this. You can strain the textile on two sides of the compression clamp. The compression clamp then has grip faces, which are serrated, male-female, sort of tongue and groove. And as you impart the load, you deform the geotextile. The textile has to have tremendous elongation to accommodate this deformation. If it does not, it will tear and rip. Here you can see a needle punch non-woven who's undergone a tremendous elongation without any failure. These are textiles that did not fare so well, and certainly in this application you would have to reconsider them. In addition to that, milled and recycled materials cannot clog up the milling machine, the textile in the overlay. This becomes quite important that you can't have large scraps of material or pieces of material clog up the drum. Some materials are better than others for milling, and there are advantages to specific materials. Also, which is important, is that the geotextile can't be damaged or brittle when it's coming off the roll. You saw the laboratory situation previously. This is a glass grid with very high modulus and having issues during the deployment. There has been some innovations which in regards to the material, Propex has introduced a new material with a new polymer for a paving textile. The performance has been very favorable, and we're seeing it used throughout the United States with great success. This application I had no idea about, to be honest with you. This was a totally new introduction to me just within the last few months. What's now being used is a heavy needle punch non-woven, either solar black or reflective white, in between pavement layers, and most notably used with concrete. I'm not talking about asphaltic concrete, I'm talking about rigid pavements. So it's used for new and rehabilitations of rigid pavements. It's replacing the HMA layer in this regard. It's functioning to unbound the concrete inner layer. So it provides a disc bond beneath the new pavement, and decreases the friction between the two layers. It's also absorbing stresses from crack movement below the new pavement. It's obviously improving hydraulics and can improve temperature and curing, particularly if it's the white geotextile. The unbonded pavement here used over Portland cement AC, and it's floating the new slab basically. It's also used over lime treated bases and has shown great success within the last year. Traditionally, we're comparing it. This geotextile layer now is a stout 14 to 16 ounce per square yard needle punch non-woven. You'll see it being installed in the next couple slides. MnDOT in I-35 used it with great success. Here you see the geotextile going down over top of the pavement and getting ready for the slip-form paver over top of it. It's being placed with this large Hilti gun on an oversized washer to hold the textile down. It does not impede the slip-form paver, and the paver tracks over top of the edge of it quite readily. Here you see an up-close photograph of it, the cage with the dowels. That will be a joint which will subsequently be placed in the roadway. The slump of this concrete is controlled, and realize it's not soupy, it's not very wet, it's placed rather stiff. The geotextile versus this HMA layer, the textile is in the neighborhood of $2 to $2.50 a square yard installed, and that compares to HMA layer, which is in the neighborhood of $6 a square yard, which is more than twice as expensive. The placement advantage, certainly you don't need any asphalt on the project, and it moves along much faster. The speed is much quicker and obviously much greener from a sustainability point of view. There is a geotextile associated with this, which is white in color. The white geotextile will have about 50-degree cooler temperatures associated with it, other than the black. This helps considerably in curing of the concrete and has been shown to be advantageous on several problems, particularly projects that are in the Southwest. There is a little bit of a change from the Hilti gun with the washer associated with it. They're spray applying an adhesive. This is typically a urethane-based adhesive. It's very fast and continuous and can move along quite quickly. I should caution you, though, these urethane adhesives do not work very well in the wet. The area has to be quite dry and free of precipitation and any overland water or water from the subgrade. Withstands construction traffic. As we mentioned earlier, these materials are not steel blasting mats. They can be damaged. What we'd like to see is controlled traffic over top of them. Obviously, the truck shouldn't have stones embedded in the treads. They should move on and off the material at right angles. They should do it at low speeds, and obviously there should be very little braking associated with it. You can do it, and that has shown to be done quite successfully. This is a application in South Dakota, a very nice installation of this, and the department was quite happy with the project. It went along without a hitch. They also had drainage associated with the textile. This report is written up in the American Concrete Pavement Association. You can find the paper on their website, and it's readily available to anybody that wishes for it. That was a lot in a short period of time. As far as a summary for the presentation, we went through unpaved roads, a favorite application and one that's been used for nearly 50 years. As far as the paved roads, we talked about the geosynthetic on the subgrade. in the base course, and then in the pavement. And we even introduced some new stuff at the end of it to show how versatile these materials are. I really think that there's a lot of future in this. The magnitude of the worldwide roadway challenge is huge, growing, and I think very exciting. I think we have a good future in this with a marriage between natural materials as well as geosynthetics. There's a lot of benefit associated with the geosynthetics, which I think is fantastic. As far as the future is concerned, I think new roads will be built and continue to be built. There's updating, a need to update old roads certainly will continue, and geosynthetics will be involved with both of that. Geosynthetics will play even a bigger role in roadway construction going forward. And I truly believe that there's an underutilization of geosynthetics in this application worldwide. I think we're just at the beginning. Our timing couldn't be better. And I think construction will really drive our economy going forward, particularly out of this pandemic. Thank you so much for listening. If you want to pass along questions in the chat, I realize there was as many as 425 people on board, but certainly you can ask questions now in the chat, and Drew will relay them to me. I'd like to thank very much Propex for their sponsorship, and Mark Marienfeld for his review. It's really been fantastic. As far as an outreach of contact information, please realize my contact information is there, as well as Fred Chuck, who is the managing director of GMA. Jessica is on here, and she's helped out greatly, as well as Janelle at IFAI. They're, as far as I know, this has worked technically flawlessly. Please realize we have questions. We answer the GMA tech line for GMA and here at the Institute. If you have questions, do not hesitate to contact me through email or to contact me through the GMA tech line. It's an honor and a privilege to be with you. And if you have questions, maybe Drew can ask me and see if we can get to some sort of consensus. Thank you so much.
Well, thanks, George. Yeah, we do have several questions. We'll try to go through these as much as we can, and you guys tell me if you have more time or not. So we'll start one at a time, and then we'll go from there. Okay, George?
Certainly.
So the first question, this is up toward the beginning of your presentation when you're talking through the comparison between different soil strengths. And there's a question about the cone index shown. Which cone index is that? Is that CPT or DCP, or is there something else?
I believe it was a CTP, very amateur, non-technical, but just a for me a standard cone.
Okay.
It was not a dynamic, static.
Next question is, and you might have answered some of these questions through your presentation, but can you suggest a geotexa which functions as a control for swelling in expansive soil where reinforcement is or as reinforcement to limit rutting? So
you caught me on this. This is in regards to membrane encapsulated soil, I believe, and you want to actually use the soil on site, the in situ soil, and you want to encapsulate that like a big longitudinal pillow or a geotextile tube. We see this by controlling the moisture content of some of those swelling soils. They could be quite adequate. They could be quite strong. It's an application that I left out of the presentation. I certainly hear you loud and clear. If that questioner wants to contact me, I'll send you a very nice paper on that. But membrane encapsulated liner systems, and it's, yes, another alternative, a geosynthetic alternative in roadways. It just was a minor one compared to these big four.
Right. Okay. The next question is, what is the most efficient fabric or grid material to use if you have high ground moisture condition?
See, this is hard for me to ask. The beauty of geotechnical and transportation industry is that it's so engineering is it's so localized. So to say a best generic one is brutally difficult for me. Can you realize that some of these things, if you're using a modified base, it's going to change the design tremendously if you want to use an open graded base. So there's so many variables involved with this that question, just a generic one size fit all, is really, I'd be hard pressed to do that. Think of these things as tools in the toolbox, and you have different tools for your use in a myriad of different applications. That's the best I can do on that one, Drew.
Okay, yeah, that's great. Um, Next question is, are there any references for anchored geotextile edges with cables? So you mentioned that application or installation procedure once. I believe that's what he's referring to. Do you have any other
Oh,
references to that?
it's a good friend of mine. It's John Guglielmetti at DuPont did it. I just gave that presentation down um, in Charleston at the last IFAI Geosynthetics conference. It was my last trip, as a matter of fact, in March. I'd gladly send that to you. The reference is 30 years old, but I'll give you entire case histories in regard to that. It's really slick and well done. Clever contractor Severinsen was the one to do it that I saw first, and worked very successfully.
Okay. Next question was, let's see, it was mentioned that the Drude-Hahn method bases benefit on tensile modulus, but in the Drude-Hahn papers, the author outlines that each product needs to be calibrated and that quote-unquote higher strength geosynthetics do not necessarily perform better. What all is included in that calibration?
I can I can sit with you and go through this, each one of those variables, and do a parametric evaluation on this. But I agree with the questioner. I was going a mile a minute here, just too fast over that, and I didn't do them justice at all. I hope JP wasn't on the line, because he would, you know, take offense, or Jihan as well. So please, I just went too quickly through that. I would gladly sit with a Zoom call or a telephone call with people to go over those equations. They're worth the effort, and I believe the update as well. For specific applications, they work extremely well.
Right, understood. Another question, this one's a little more specific. For pavement applications, fatigue performance of the geosynthetic material is not often discussed. Shouldn't it be a point of discussion, and why? So specifically, why only monotonic tensile strength are they considered criteria for geosynthetic materials? So essentially, what fatigue or durability performance criteria should be considered for geosynthetics?
I tell you, it's complicated. To bear out these nuances in laboratory studies, and then to see that in the field, has been fraught with problems. A lot of folks have spent a lot of money on this. Um, my favorite study is a fellow by the name of Tom Kinney up in Fairbanks, Alaska, and he's talking about the movement there being elliptical almost, as the over the roadway. I think those stresses are extremely complicated. I think we need to monitor the geosynthetics by themselves. I think there's a bunch of new microtechnology which might lend itself to that. I think some of these new items with smart aggregate and smart geosynthetics will give us the answer. It's involved, is what I need to say. There's some very good work being done at the University of Texas at Austin by Jorge Zornberg. I know the folks out at Penn State have used these techniques, and I think we're going to see a lot in the future. Do I have a beautiful answer to you? What the stress state in the geosynthetics are at this time? No, and I think that's we're on the cusp of that, though.
Okay. In the separation section of the presentation, you talked about specifically nonwoven geotextiles. Is there a reason why we would use nonwoven geotextiles versus woven geotextiles for separation?
I worry about the woven textile in regards to maintaining its opening size. Heavy needle punch nonwoven has shown its performance in this regard, and I think it's while it's adopted statewide in states like Pennsylvania, it truly is, has shown its performance over time.
Okay. Another question was, and we just so we know, we have a lot of questions. We probably won't be able to answer all of them here. We'll dive in the rest of them offline, but we'll do a couple more. So the next question: when you eventually dig up a geotextile separated road or a roadway with a geosynthetic in it, how much trouble is it to get the geosynthetic out of the aggregate? Specifically to mix and recycle the base material? Will it clog up a screen machine? Will it clog up a full depth mixer? How can that be used, or can it?
Depends what textile it is. So you're digging up a full depth repair. Is that it, Drew? Or you're digging up?
I believe that's the question. Yes.
I don't know if you would use the right textile. You wouldn't mess with anything other than the surface. You wouldn't go after the aggregate would still stay in place. I certainly need you to, that's the objective of using a geotextile separator. I don't know of any way of pulling the geotextile separator out if you were doing the full depth repair, if that's the question. The geotextile isn't strong enough to do the Houdini trick and mobilize that aggregate.
You're right, and that's the hope, is that the geosynthetic is doing its job, and so you can focus on the pavement above that section.
Agreed.
So another question: do you see the use of geosynthetics in permeable pavement applications?
I do. You have a bunch of composites which are on the cusp for that. Didn't address that at all. It's yet another area where there's big inroads for this. There's tremendous potential in that regard. Just didn't have time for it in this relatively short 1-hour presentation. Can direct you for research papers on that. Please drop me an email. I'd welcomely do that.
Okay, and we'll probably do one more. Are you able to comment on the use of three-dimensional geosynthetic options like geocells, for example, for paved and unpaved roads, and how they compare to the geosynthetics you covered, more two-dimensional materials?
Wow. Yes, is the answer. There's a tremendous thrust with cells and geosynthetics with a third dimension. Again, I missed out on that. Tremendous savings in areas that do not have aggregate. There are parts of the world that don't have a quarry, that don't have anything but sand. Wouldn't it be nice to use a three-dimensional grid or a three-dimensional cell in those applications? There is currently activity in ASTM. Eli Quayler is championing this work in ASTM as far as a guide for geocells being used in this application. Yet another item where I missed. I could introduce that as well. Sorry about that, but just so much going on right now, and but there's an avenue for that.
Well, George, you definitely covered a lot of material, a lot of different applications in a short amount of time, and I feel like you did it very well. So thank you for your time and answering the questions. We have a lot more questions that will get answered offline for you guys. Again, thank you, George, for your time and effort for this. Thanks everybody else for joining in and listening on the webinar. Thank you for your time and have a good week. Thank you, guys.
Okay, take care now.